All right, hello everyone. Welcome to the MicroJIT meeting for the 8th of October. So as usual, I think it's probably best for us to start off with an update from Scott on all the things that have been going on at UNB on the contribution side of the MicroJIT project. So Scott, take it away.
Thank you very much, Marius. Or sorry, Andrew. So first, I'd like to thank Marius because he's been helping me the past week or two figuring out some bugs with GCR. And as of about an hour and a half ago, I can now confirm that in GDB, I can compile a method with MicroJIT, with GCR code emission, that GCR code emission, when GCR is enabled, eventually executes. We can then send that request for recompilation, and that when we send that request for recompilation, it is compiled by TR instead of MicroJIT. So we have GCR recompiling. The problem there is that first bit in GDB. So that is the only thing I have yet to figure out and fix, and I'm not sure why it's happening. But in GDB, I get, once I set my breakpoints, after executing the breakpoint that is set inside of the MicroJIT method a number of times, I eventually get some updates from the verbose output on the JIT state. It says that the VM changed state to not start up. Then it says that the JIT changed state from startup to idle. I execute the breakpoint a few more times, or continue and hit the breakpoint a couple more times, and eventually I get an info that says GCR enabled, GCR queued equals 0. And it's after that, almost immediately, that we get the recompilation event, which is because of some settings I have set up for testing. The count is for going from MicroJIT to TR is essentially 0 for these tests that I'm running. Then when I run it without GDB, I do not get those messages about the VM state changing. And instead, I get things related to the aggressiveness of inlining slowly decreasing. And I never see a thing that says that the VM changed state to not startup. Never see that the JIT state moves from startup to idle, and never see GCR get enabled, which leads me to believe that without GDB, we're not getting into TR compilations. And I don't know enough about how the mechanisms of the VM decide when to enable GCR or not to know what could be getting triggered asynchronously by setting breakpoints in GDB that wouldn't be triggered when running outside of GDB. So on the MicroJIT side, things are working, but I'm wondering if we need to change something about the state of how the VM decides when it has moved to not start up, and decides, or when it decides to enable GCR, to prevent the VM from simply running everything with MicroJIT and never counting.
So quite complicated, and we can solve this offline. I would like to know what is the program that you are running.
So it's actually a very simple test program.
And
I'll just pull it up here in front of me very quickly.
And do
so
we
the
spend
test
a lot
program? I'm sorry, what was that, Marius?
Yeah, do we stay a lot of time? Do you spend a lot of time in this program, or is it just something very easy and you exit?
Oh, a long time. It's 2 nested for loops that go from 0 to 1,000,000, and then every 1% of the, or rather, every time the outer loop is 0 mod 10,000 for the first iteration of the inner loop, we print out the result of calling the function we're compiling, which is just a simple add function. We add 2 integers together and return it. So the method we're compiling is really simple and really small, but we run it a large number of times over and over and over and over again.
I think we should exit the startup at some point. Nevertheless, so one data point is run without MicroJIT and see if you trigger those states as you've seen them in GDB, because there shouldn't be any difference between running with MicroJIT or without. And then have to look at your program to see what the states are, and whether or not it makes sense and whatnot. So please collect a verbose log from running the program, even without MicroJIT. So let's not complicate things. And I'll try to make sense of it, and then I'll let you know what you need to do in order for the states that you want to be triggered. And if you collect a verbose log with a compiled performance, even I think there are lines that say when GCR is enabled or disabled.
Yeah, that was what what I did previously with that GDB to determine that this state thing was what was the problem. Because I see shortly after it changes states, like when the JIT changed state from startup to idle, we only executed the method, it looks like 10 more times before GCR was enabled. And then when GCR was enabled, we were in the middle of starting a call to this method, and we immediately hit the request to recompile.
So the way you describe me the program, I think the typical sequence of states should be startup, then steady, no idle, steady, and then deep steady. And GCR counting is not allowed in startup because we don't want to penalize startup with recompilations. And I think it's not allowed in deep steady state. So there is only a short window of time, the steady state, where GCR counting is enabled, or that's how I imagine this program should behave. But let's see the output from the verbose log.
Okay.
Marius, if I may, a question for you on the longer term for this. Is it likely that we'll want to have a separate kind of GCR flag for the MicroJIT body, since we may want to get out of those with TR compilations slightly differently than the TR GCR compilations, or do you think that they should stay alias?
No, yeah. So once we have the infrastructure ready, I think there is an entire slew of heuristics that could be changed and need to be changed.
Okay, but you'll be happy for the initial contribution to basically alias the flag, like use the flag for the two purposes, and then we'll disassociate it later.
Yes, correct.
Okay, sounds good. Just wanted to confirm the plan there. Thanks.
All right, so that's more or less where we are on GCR. My expectation is that when I generate those logs and work with Marius, that we should probably be able to fairly quickly fix that up. And then once that's done, we should be able to update the PR with this GCR change. At that point in time, I intend to start looking at the emission of profiling instructions. And I believe currently, or very shortly, Harpreet, who's on the call, will be transitioning off of the most recent bytecode that she was implementing and beginning the work of porting the properties structure that's used by TR in many of its linkages to a non-TR specific state so that it can be used by MicroJIT and TR. And I believe there was some rewrite that Daryl was looking to do with some of the linkages before. And as part of that, we're hoping to have that properties thing done fairly soon, so that can be part of that rewrite.
Yeah, that's true.
All right, so I believe Harpreet had some questions related to the properties. So I'll pass it over to her for any questions she has related to the refactoring of properties.
All right, thank you. And hello, everyone. Um, so I have been looking into the properties thing, the current linkage properties. I have some questions in that context. Like, I just want to ask whether where we are currently using the linkages in TR. Like, I see some linkage. When I look at the code of the OMR code generator, so I see that it has the statements, the instructions which are using the TR x86 linkage properties. So is that the only place we are using the linkages, or are there some other places also? I just want to ask that because I just want to know what are the places where we have to look into, like while testing that after implementation, we are not breaking the code.
So the linkages are used whenever a method call or any kind of function call from compiled code. So the predominant linkage used in Java is what we call private linkage.
Yeah.
That is actually defined in the OpenJ9 project, and it extends the linkage that is it extends the base linkage that lives in OMR. So OMR will produce a TR, in the TR namespace, a linkage class, a concrete class, and then private linkage will extend that. The other kinds of linkages that are common are system linkage. So that, I believe, is defined in OMR because it transcends Java. It's useful in non-Java projects as well. Now, when you're looking at the properties, I believe it's true. I believe if you're just looking at where the linkage properties are being consulted, I think it's true that they are only consulted in perhaps some base function that lives in OMR. So it might actually all be in one place, if I'm not mistaken, like in one particular method or function in the OMR, in the base OMR linkage class. So you have to kind of look at who's calling that method and kind of build up a bigger picture to understand how those properties are actually being used. But I can tell you that they are being used by multiple linkages. It's just that the query might be in a fairly base location. Did that answer your question?
Yeah, okay, all right. So for that thing, we don't have a specific like documentation or somewhere documented like what are the files which are actually using the TR. We just have to do the find in files and then we can move further along that. Is that true?
There's no standalone documentation for linkage, unfortunately. What specifically are you looking for? You want to know all the places that are consulting the properties of a linkage?
Yeah.
Yeah, I mean, the best way to find that out is really just to grep through the code. But what I was trying to say earlier, though, was you can't necessarily just look at who's accessing that. Like, I think you need asking that question to get the bigger picture of who's reading that. Now, where we tend to access when we need to know the properties are typically when we're doing we're building the in a couple of different places. So we're doing a method dispatch, and we need to ask questions like what are the volatile registers? What are the integer argument registers, what is the return register, things like that. So you'll find all of that code typically in, where would you find that? You'd find it, well, in each linkage class, there are two functions. One is build direct dispatch and one is build indirect dispatch for doing obviously direct and indirect calls. So you can use those as your starting point for looking to see how those properties are used during a method or a function call. I think those are they both virtual? They might both be virtual functions. I don't remember off the top of my head.
Okay.
But you can use that as a starting point. So that's on the caller side. Where the properties are also used are on the callee side when we are constructing the prologues and the epilogues for a particular method, and we need to understand what registers need to get preserved. Where can I find the like the return address of the caller frame, other sorts of displacements that are unique to that linkage. Those are all consulted when we're building the frame. So in the linkage class, there's two major functions for that. There's create prologue and there's create epilogue. So those describe that. And then the other thing, actually, I don't think we consult much of. I was going to say the map stack function, but I don't think that is, actually, I don't think that really consults the linkage properties per se. But certainly the create prologue and create epilogue will. So on the callee side. So that's a place for you to focus on. And if you're looking at OpenJ9 and you're trying to understand the system linkage, or you're trying to understand the linkage it's using, you need to be in the OpenJ9 side and just under the X directory on OpenJ9, look for files that have the word private. So there'd be like an x/cogen/x86 private linkage.cpp, something like that. And then there's AMD64 specializations of that, I believe. So you should be able to find your way away. If you're having trouble finding stuff, just ping me. I'll help you out.
Okay. Yeah, that would be fine. Okay, all right. And next question I have is regarding testing the implementation. Like after we implement, how do we test that implementation is correct and I did not break the existing code? Like, do we have some existing standard test suite for that or some benchmark, or do I write like some random tests of my own from scratch?
So specifically, I assume what you mean by that is you want to test TR.
I want to test the TR with new implementation after implementation.
So, I mean, in OMR specifically, there are a couple of sort of standalone tests that we use for doing some very basic unit operations on linkages. I don't think that necessarily applies to you. Java tests, we don't actually have any unit tests that I'm aware of that are trying to stress the linkage. The good thing about linkage is that it's used a lot. Like pretty much you run if you compile a lot of methods, call a lot of methods, you're exercising the linkage paths a lot because functions or methods have got different numbers of parameters. They have different return types. They have different stack sizes, things like that. So a lot of that code tends to get executed quite a bit. So the more, it may not sound like a great answer for you, but the more tests we actually run, the more that your code is obviously going to be executed in different scenarios. So now, having said that, though, there is certainly the opportunity to create some unit tests that do stress some of the properties of the linkage. So you could write some Java unit tests, like methods that have, 16, 18 parameters, mixtures of floating point and integers, things that we know will get passed on the stack, things that we know that won't, things that have got static methods and not, returning different things, methods that have a lot of locals that are going to be allocated on the stack, so things like that. So it's possible to create some unit tests for some of this work, and I'm not going to discourage you from doing that. It might be a more targeted way. Like if you're specifically looking to see that a part of your code is being exercised, that might be a more targeted way of doing it, by running a test that, if you want to make sure that your floating point registers are being allocated properly, obviously you're going to need to have a test that has enough floating point parameters to make that interesting. Or if you want to make sure that you use all the floating point linkage registers and you now need to start passing floats on the stack, then you need to make sure that your signature is wide enough to contain more than 8 floats in it. So you may end up creating your own test for that purpose.
Okay, all right. So that answers my question. And the last query is related to this. Like that is more or less for Andrew. I wanted the recording for our 4th meeting, which was held on 13th August. I just couldn't find it on YouTube.
Okay, I'll go have a look. Maybe it got missed in the uploads. I should have the recording still in the WebEx, so I can try and upload it.
Yeah, maybe.
I'll go have a look. I've certainly recorded them all, so it's probably just missed in the uploads.
Yeah,
I'm looking at it here now, and I see a number of Eclipse OpenJ9 MicroJIT meetings that went up a week ago. Looks like 0910 and 0924. So I believe the MicroJIT calls are getting uploaded somewhat offset.
Yeah, so previously I had to go through one of the project leads. I'm now being granted access to the YouTube channel directly, so I can upload more quickly. So that was just a function of how the project was operating. So the delay should be shorter now going forward.
Okay.
yeah, okay. Yeah, go ahead.
Anything else from you, Harpreet?
Yeah, I just wanted to add on that till now we had 6 total MicroJIT community calls, and we have the recordings of 5 of them on YouTube.
Okay, I'll find the missing one and put it up there.
Perfect, thanks.
Yeah, and I would add for the linkage testing for x86, make sure that you're testing both the 32-bit and the 64-bit versions when you're doing your testing on that. The 64-bit is exercised quite extensively, but there's fewer people that run the 32-bit one, but the platform is still supported. So you'll need to make sure you exercise both since they have different behaviors.
I had a lot of trouble previously getting the 32-bit version compiled and executed. Do you have any scripts for building it that I could have a hold of, Andrew?
Well, the standard way to do it would be to use the appropriate Docker image and then clone make like you normally would for an OpenJ9 build and just build the whole thing. That should work.
Scott, you're just asking about building OpenJ9 on 32-bit Linux, let's say.
Yeah, because when we initially started this work with MicroJIT, the original MicroJIT compiler, because we started by trying to port the original MicroJIT compiler from some previous work in 2016, and it had been tested on 32-bit Windows. And one of the tasks we had was to port it to 64-bit. But in trying to just compile and run the 32-bit Linux version, I spent, I think, 2 weeks trying to get it, and I just couldn't get it to compile.
Okay, it might. So the instructions should be pretty much the same as 64-bit. It might be worth trying it with the Docker container, like Andrew suggested, because you may have a toolchain issue building on 32-bit. So try it that way first, and if even that doesn't work, then we're going to have to diagnose what the issue might be.
And before we weren't using Docker, and we're still not using Docker at the moment. Right now, we're building in virtual machines in Hyper-V and doing our development on those virtual machines. So I imagine at some point in time that if we're going to be testing things across multiple architectures, that Docker and getting that tool chain set up is going to be important.
Yes. Actually, you can test things with Docker. I mean, my personal experience with it has been that it's a little bit slow for doing any significant testing with it. It's fine for some things, but if you're doing a lot of testing, it might be a bit slow. What you might want to do is to take the configuration, like how that container is set up, take that initialization, and then make sure that your local environment has all those dependencies installed, and then you can do your builds natively then.
Yeah, that was what we did when we set up the virtual machines originally, was go through the...
Oh, really? Okay.
We went through the Docker images. Yes. However, I'm expecting that that may have been due to some sort of configuration thing that possibly isn't as obvious to see. Like, I know when one of the things that was a problem was the GCC that was installed the 64-bit versions of several libraries, and getting it to install the 32-bit ones at the same time and link them correctly, and having everything set up so I could compile things with -M32 was a bit of a hassle. It wasn't as obvious or as straightforward as simply copying the Docker file, which is what we did with the 64-bit setup. We just copied the Docker file and used that to set everything up.
Well, if I'm not mistaken, though, the 32-bit builds are done on 32-bit OS with the 32-bit toolchain. I think it's like the whole thing is 32-bit when we do that.
Yes, and we're doing a 64-bit machine, and we're running things in Hyper-V with no emulation, or, well, with the minimum amount of emulation.
Okay.
Doing hardware virtualization.
Right.
Now that I'm just thinking about it here, I don't think these are actually for 32-bit. They're all talking about 64-bit. So we might need to dig a little bit deeper into how some of the testing is done on OpenJ9 to understand how those machines are configured in order to give you the instructions for configuring a machine for doing a 32-bit build. Unless someone on this call knows differently about they should work on 32-bit. It appears to be 64-bit only.
I'm not aware of anyone on OptiNext that's doing builds on 32 specifically for dev. I think people are mostly just doing the dev on 64, and then the testing is done on one of the farms using the pre-built images that are there.
Yeah.
For a lot of things, the 32-bit doesn't really matter, right? But for the linkages, it's especially important because of the register constraints and stuff on 32-bit.
Yeah, I mean, I would say that don't.
You go ahead, Daryl.
Well, I was just going to say, I wouldn't necessarily let 32-bit distract you at this point. I mean, obviously, we're going to have to run some testing on 32-bit when you've done some changes to the linkage to make sure that it works fine. But wouldn't want the fact that you can't build on 32-bit right now to impede any kind of progress you want to make on 64-bit. So, I mean, obviously we'll have to address that when the time comes, but the time might not be right now.
That's fair.
Okay. So that means currently we can test it for the 64-bit, and then for sure we'll have to do it for 32-bit maybe later.
Yes, for sure later.
All right.
Yeah, I was just mentioning it so it didn't get forgotten. I wasn't meaning to make it the priority right now. It's just people tend to forget about the 32-bit platform because not a lot of people build for 32-bit targets, but it's caused us grief in the past. So
Yeah, got it. I got the point.
Excellent. Okay, so is there anything else you wanted to ask Harpreet?
No.
Oh, okay, perfect. So I noticed that Georgi asked something in chat just before we started talking about properties related to the state changing. And he's asking specifically about if the problem I'm having could be related to startup method don't downgrade threshold. And I'm completely unfamiliar with it, so I don't know what it is, and I can't answer his question. Does anyone know what that might be, and if that could be something that would change while running in GDB?
I'm not 100% certain, but I suspect it's something. Usually the downgrade is related to the op level downgrade from warm to cold. There's probably some control heuristics there. Marius may know a little bit more, but it doesn't sound like something that's immediately GCR related just from the name. I'd have to go check more deeply, but it sounds more like an op level detail to me.
What is that question again?
So the question he had was, he was asking if the problem that I was seeing could be related to startup method don't downgrade threshold. It was something that helped him when he was trying to force JIT compilations. And he was asking, and he was stating that it was something related to not compiling short methods.
Doesn't ring any bell, but I have to scan the code.
All right. Well, if we get stuck going through the state transition thing, then we can put that on the back burner and see if that's a thing that we need to look at after. All right. So I guess that's it from Harpreet, and that's it from me. Is there anything that any of you guys at IBM wanted to talk about related to MicroJIT and our next steps now that once GCR should be finished soon, and there will be a new PR up when that happens, or not a new PR, but an update to the PR.
Doesn't sound like anybody's got anything else. I think it'll be great to see the update to the PR. I think it's just we'll still be waiting for some of the linkage stuff. I think before it might get merged, we can have that discussion on the PR. But it's certainly good progress, and I'm delighted to hear that you've gotten it working and that the need for the extra 2 field and everything should go away. So that's great, and it provides a much better integration story. So. Thank you very much for taking on board the feedback and for working so diligently on that hookup. It's certainly non-trivial, so the effort is certainly appreciated by the community.
Thank you very much. And thank you for all the help and for setting up these meetings. It's been very helpful for trying to get more progress on the project and trying to push ahead to get this eventually merged in and contributed.
Okay, so last call for any other comments or any other business. Okay, I'm not hearing anything, so we'll close the meeting there. We will meet again in 2 weeks as usual. So that'll be the 22nd of October, I believe that makes it. I'll post the meeting link and a reminder in the OpenJ9 channels as usual. I will endeavor to make the recording available as soon as I can. There is a delay with WebEx, but I will try to sort that and the missing recording. Thank you for calling that to my attention. And everyone have a great day, and thank you for attending.
Thanks, everybody. Have a great day.
Thank you.
Thanks, everyone. Bye.
Bye-bye, everyone.